Why does fire exist? Simple question. You've seen fire 1,000 times. Campfires, candles, stoves. You strike a match, something burns, flames appear. But why? Most people never ask. Fire just is. It's hot. It's bright. It destroys things. That's all you need to know, right? Wrong. When you really ask what fire is, when you dig into what's actually happening when something burns, you discover something so beautiful, so perfectly connected to everything else in nature, that it changes how you see the world. Fire is not just a thing that happens. Fire is a window into how atoms behave, how energy moves, how the sun powers everything, music, and why trees exist in the first place. Let me show you. Clear his throat. Start with a piece of wood, dead trees sitting there doing nothing. And air, oxygen in the air, floating around, also doing nothing. The wood has been sitting there, the oxygen has been there the whole time. Nothing's happening. They're just there. But the atoms like each other to different degrees. Oxygen, for instance, in the air would like to be next to carbon, and if they're getting near each other, they snap together. But here's the problem. If they're not too close, though, they repel and they go apart. So they don't know that they could snap together. This is the fundamental tension. Carbon and oxygen want to be together. Being together releases energy, a lot of energy. That's the stable state, the low energy configuration. But to get there, they have to first get close. And getting close means climbing over a barrier. It's just as if you had a ball that was trying to climb a hill and there was a hole it could go into, like a volcano hole, a deep one. It's rolling along. It doesn't go down in the deep hole because if it starts to climb the hill, it rolls away again. But if you could make it go fast enough, it'll fall into the hole. And so if you have something like wood and oxygen, there's carbon in the wood from a tree, and the oxygen comes and hits the carbon, but not hot enough. It just goes away again. And the air is always coming. Nothing's happening. The atoms are bouncing off each other constantly. Millions of collisions every second, but they're not reacting because they don't have enough energy. They hit, they bounce, they separate over and over. The wood just sits there. The oxygen just floats around. Nothing changes. This can go on for years, decades, centuries. A piece of wood can sit in the presence of oxygen for 1,000 years and nothing happens. The atoms want to react, but they can't get over that barrier. If you can get it faster by heating it up somehow, somewhere, somehow get it started. A few of them come fast. They go over the top, so to speak. They come close enough to the carbon and snap in, and that gives a lot of jiggly motion, which might hit some other atoms, making those go faster so they can climb up and bump against other carbon atoms. And they jiggle, and they make others jiggle, and you get a terrible catastrophe, which is one after the other. All these things are going faster and faster and snapping in, and the whole thing is changing. That catastrophe is a fire. It's just a way of looking at it. And these things are happening. They perpetuate. Once it gets started, it keeps on going. The heat makes the other atoms capable of reacting to make more heat, to make other atoms, and so on. This is the key to understanding fire. It's not that something magical happens when you light a match. It's that you're giving a few atoms enough energy to get over that barrier. And once they do, they release energy. That energy makes other atoms move faster. Those atoms get over the barrier. They release more energy, and so on. It's exponential growth. One reaction triggers two. Two trigger four, four trigger eight. The number of reacting atoms doubles and doubles and doubles within a fraction of a second. You have billions of atoms all snapping together simultaneously. That's why fire explodes into existence. It's not gradual, it's sudden because it's a chain reaction, a runaway feedback process. So this terrible snapping is producing a lot of jiggling. Snorts. And if I put, with all that activity of the atoms there, a cup of coffee over that mass of wood that's doing this, it's going to get a lot of jiggling. So that's what the heat of the fire is. Heat is not a substance. It's not a fluid that flows. Heat is atomic motion. The faster atoms jiggle, the hotter something is. When fire releases energy, that energy goes into making atoms move faster. That's heat. That's temperature. That's what you feel when you hold your hand near a flame. Fire is not a substance. It's not a thing. Fire is a process. It's this catastrophic chain reaction where atoms are snapping together faster and faster, releasing energy, making other atoms move faster, which makes more atoms snap together. It's a cascade. Once it gets started, it feeds on itself. The heat from the reactions provides the energy needed to make more reactions happen. It's self-sustaining. That's why fire spreads. That's why it's hard to stop. The heat makes atoms jiggle fast enough to react. The reactions produce more heat. The more heat makes more atoms react around and around. A feedback loop, and the only way to stop it is to break the loop, cool it down below the threshold, remove the fuel, remove the oxygen, cut off one leg of the triangle, and the process collapses. And then, of course, if you see, this is what happens when you just start to think. You just go on and wonder, how did it get started? Why is it that the wood's been sitting around all this time with the oxygen all this time, and it didn't do this earlier? Where did I get this from? Well, it came from a tree. And the substance of a tree is carbon. And where did that come from? That comes from the air. It's carbon dioxide from the air. People look at trees and they think it comes out of the ground, that plants grow out of the ground. But if you ask where the substance comes from, you find out, where does it come from? The trees come out of the air. They surely come. No, they come out of the air. This is one of the most beautiful misunderstandings in all of nature. Everyone knows trees grow from the ground. You plant the seed in soil, the tree grows. Obviously, it came from the soil, right? Wrong. The carbon dioxide in the air goes into the tree and it changes it, kicking out the oxygen and pushing the oxygen away from the carbon and leaving the carbon substance with water. Water comes out of the ground, you see. But how did it get in there? It came out of the air, didn't it? It came down from the sky. So, in fact, most of a tree, almost all of the tree, is out of the ground. I'm sorry, it's out of the air. There's a little bit from the ground, some minerals and so forth. The minerals give you the ash when you burn wood. That tiny bit of residue left behind, that came from the ground. But the wood itself, the bulk of the tree, the substance that burns, that's carbon from the air. That's water from the rain. Almost nothing came from the soil. Now, let me prove it to you. Your clear's throat. Take a pot of soil, weigh it, plant the seed, water it for years, let the tree grow big and heavy. Now, dig up the tree and weigh the soil again. The soil weighs almost the same as it did before, maybe a tiny bit less. Some minerals got absorbed, but the tree weighs hundreds of pounds more than it did as a seed. Where did all that mass come from? Not from the soil. The soil didn't lose hundreds of pounds. It came from the air. This experiment has been done. The Dutch scientist Jan Baptist van Helmont did it in the 1600s. He was trying to figure out where plant mass comes from. He weighed everything carefully. The soil barely changed weight. The tree gained enormous weight. He concluded correctly that the tree did not come from the soil, but he thought it came from the water. He was close. The water is part of it, but most of the mass is carbon pulled directly out of carbon dioxide in the air. Now, of course, I told you the oxygen and carbon stick together very tight. How is it the tree is so smart as to manage to take the carbon dioxide, which is the carbon and oxygen nicely combined, and undo that? The universe is full of metastable states, systems that want to release energy but can't get started. Wood and oxygen, gasoline and air, food and oxygen in your cells. They're all waiting for a trigger, a spark, an enzyme, something to get them over that initial barrier. And once they start, they run on their own. Here's another thing that should blow your mind. The oxygen in the air. Where did that come from? From trees, from plants, from photosynthesis. For billions of years, plants have been ripping carbon dioxide apart, keeping the carbon and spitting out the oxygen. All the oxygen you breathe, all the oxygen in the atmosphere, it's waste. It's a byproduct. Plants don't want it. They throw it away. The early Earth had almost no free oxygen. The atmosphere was carbon dioxide, nitrogen, water vapor. Then photosynthetic organisms evolved. They started dumping oxygen into the atmosphere as waste. For them, oxygen was poison. Many of those early organisms died out when oxygen levels rose. But some organisms evolved to use that oxygen to burn food with it, to extract energy from it. And that oxygen is what makes fire possible. So here's the cycle. The sun shines. Plants use that sunlight to break apart carbon dioxide, building themselves out of carbon and releasing oxygen. Animals, including you, eat the plants or eat other animals that ate plants. And you burn that carbon, combining it back with oxygen to release energy. That burning happens inside your cells. It's called respiration. It's the same process as fire, just slower and more controlled. You're taking carbon-based molecules and combining them with oxygen to release energy. The carbon dioxide you exhale is the same carbon dioxide the plants absorbed. It's a cycle, sun to plants, to animals, and back. Carbon circulating, oxygen circulating, energy flowing. Fire is just that cycle, sped up and visible. When you burn wood in a fireplace, you're doing exactly what your cells do when they burn sugar. Same reaction. Carbon plus oxygen makes carbon dioxide and releases energy. The only difference is speed and control. Your cells do it slowly, carefully, capturing the energy in useful molecules like ATP. Fire does it all at once, releasing the energy as heat and light. But it's the same chemistry, the same process. You are, in a very real sense, a slow fire. Let me make this even more concrete. When you burn wood, you're converting chemical energy into heat and light. The chemical energy was stored in the bonds holding the wood's molecules together. Those bonds took energy to create. That was the sunlight the tree absorbed, breaking the bonds and forming new bonds. Carbon dioxide and water releases that energy. The heat you feel, that's atoms jiggling faster because energy was released. The light you see, that's atoms and molecules getting excited. Literally, electrons jumping to higher energy levels and then falling back down, emitting photons. When carbon and oxygen snap together, the energy released doesn't just disappear. It goes into motion, atoms moving faster, molecules vibrating, electrons jumping to higher orbits. And when those electrons fall back down, they emit light. That's the glow of the fire. That's the flame. Different atoms emit different colors. Sodium makes yellow, copper makes green, strontium makes red. That's why fireworks work. Different chemicals burn with different colors because they have different electron configurations. If the smoke, that's tiny particles of carbon and other stuff that didn't fully react, floating up because they're hot and less dense than the surrounding air. The ash, that's the minerals, the stuff that wasn't carbon, the bits that came from the soil. That's the tiny fraction of the tree that didn't come from the air. Everything else, the carbon, the hydrogen, the oxygen, has turned into gas, carbon dioxide and water vapor, invisible products floating away. The mass didn't disappear. It turned into gas and drifted off. Now, here's the question you should be asking. Next question, how is it the sun is so jiggly, so hot? That's a different story. I've got to stop somewhere. I'll leave you something to imagine. So easy. Life has some mysterious force. No, the sun is shining, and it's the sunlight that comes down and knocks the oxygen away from the carbon. So it takes sunlight to get the plant to work. And so the sun all the time is doing the work of separating the oxygen away from the carbon. The oxygen is some kind of terrible byproduct, which it spits back into the air, leaving the carbon and water and stuff to make the substance of the tree. This is what makes life on Earth possible. The sun is doing work, real physical work. It's pumping energy into the system. That energy gets used to push systems away from equilibrium, to create order out of disorder, to build structure. Trees are constantly doing this, sucking in carbon dioxide, tearing it apart, building themselves out of the carbon, releasing the oxygen back into the atmosphere. That's what photosynthesis is. It's the tree using energy to undo what fire does. Fire takes carbon and oxygen and snaps them together. Trees take carbon dioxide and rip it apart. The tree is using sunlight to do work, to store energy, to build structure. And that structure, that's potential energy. The carbon and oxygen are held apart. They want to be together, but they're separated. Energy is stored in that separation. And then, when we take the substance of the tree and stick it in the fireplace, and there's all the oxygen made by these trees and all the carbon, they would much prefer to be close together again. And once you let the heat get it started, it continues. And it makes an awful lot of activity while it's going back together again. And all this nice light and everything comes out, and everything is being undone. You're going back from carbon and oxygen back to carbon dioxide. And the light and heat that's coming out, that's the light and heat of the sun that went in. So it's sort of stored sun that's coming out when you burn a log. Think about that for a second. The tree spent years collecting sunlight bit by bit, photon by photon, using that energy to pull carbon out of the air and build itself. It stored that energy in its structure. Then you cut down the tree, you let the wood dry, you stack it in your fireplace. The carbon that the tree worked so hard to separate from oxygen, 10 years ago, 50 years ago, stored as chemical bonds, released all at once. Every photon from the fire is, in a sense, a recycled photon from the sun. The energy is the same. It went in as sunlight, got stored as structure, and comes back out as firelight. Now, you might ask, why doesn't the wood just spontaneously catch fire? If carbon and oxygen want to be together so badly, why do you need to light a match? Because of that hill I mentioned earlier, the activation energy. At room temperature, the atoms aren't jiggling fast enough to get over the hill. They're bumping into each other, but they're not reacting. The wood and the oxygen are stuck in what we call a metastable state. They want to react, but they can't get started. It's like a boulder balanced on top of a hill. It wants to roll down. That's the lower energy state. But it's sitting in a little depression at the top. It's stable as long as nothing pushes it. But if you give it just a little nudge, it rolls down and releases a lot of energy. That's what the match does. It provides the nudge. It heats up a small region of the wood, making those atoms jiggle faster, getting them over the activation barrier. Once a few reactions start, they produce enough heat to trigger more reactions, and the fire spreads. This is why things don't just spontaneously combust.